we have looked at proofs in class, but all the proofs we've done so far have been algebraic proofs, solving equations and giving reasons for those steps. So first of all, let's define what is a proof. We've been doing them. So I would define a proof as a logical argument that uses deductive reasoning to show a statement is true. Because that's what we do. We use deductive reasoning. Everything is very logical. It's a logical argument, and to prove something is true. So this first one is just an example, okay? We're not doing anything, but I want to talk through it. So you're going to be given angle 1 is congruent to angle 3, and we can see that those are marked on the diagram already. I'll just accentuate it a little bit. We want to prove that, and maybe I'll highlight it here, that DBA, so this, it's hard to highlight, DBA is congruent to oops, gosh, that's not showing up at all, EBC. Okay, so let's take a look. We would always start with the given, okay? So we start with angle 1 is, the measure of angle 1 is congruent or equal to the measure of angle 3. Okay, so we have that. Now, when we look at this, we can look at the diagram, and we want to talk about angles 1, 2, and 3. And we want to focus on these things as well, right? So let's look at the picture. See how DBA, that angle, is angle 2 and angle 3 all together? And so that's what we're going to say next. We're going to say the measure of angle DBA is the measure of angle 3 plus the measure of angle 2. And that is angle addition. We learned that you can add angles together to make bigger ones. Similarly, we've got, I know, I see. I was going to do the other one, which you could. Like, I was thinking of doing this one next, but that's okay. It doesn't matter. So they did the measure of DBA. What they did was they substituted. Since the measure of angle 1 equals the measure of angle 3, see how they substituted there? And then what's good is, and we would eventually have to do that because, or somewhere else, but we would have to use that substitution, because then we can define and I don't know why they wrote it backwards, but I would say the measure of angle EBC is the measure of angle 1 plus the measure of angle 2. And then notice that we have DBA is 1 plus 2, and then we have 1 plus 2 equals EBC. I think they wrote it that way just to really illustrate the transitive property. But then, transitive property of equality. Had you said substitution, that would be okay too. But it is transitive since everything's equal. All right, so let's take a look at this one. Complete the proof. So look at the diagram, right? We've got T as a midpoint. We've got some measurements indicated. So let's do this together. T is the midpoint of SU. I hope we can all do this one. Given. Okay, so here's where, when we start writing our own proofs, so this one, technically, by definition of midpoint, they probably said congruent. If you started with that, I would be okay with that too. Just because we know when it's midpoint, it breaks it into 2 congruent or equal segments. I'm not going to be overly particular about saying congruent, then saying equals, and blah, 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 as long as we can follow your reasoning. So definition of midpoint It breaks, midpoint divides a segment into two congruent segments. And then if those two segments are congruent, then their measurements are equal. And that's how we define congruency. So what happened here? What happened when we went from 3 to 4? Well, instead of ST, we have 7x, and instead of TU, we have 3x plus 20. So that would be a substitution. They substituted. Now, we know the next reason is subtraction. So now it's a matter of solving this equation. So if we subtracted 3x from both sides, we would end up with 4x equals 20. And then finally, to go from 5 to 6, we would use that division property of equality. So we're going to be doing stuff like that today, giving statements and reasons, getting ourselves used to geometric proofs. Now, as a reminder, those reflexive, symmetric, transitive properties we learned yesterday, they apply to segments and angles, okay? So same thing, any segment or angle is congruent to itself, like angle B congruent to angle A means angle A congruent to angle B, and then that transitive property. Okay, so we're going to name each property that the statement illustrates. Now, again, I'm not going to be overly particular. We don't have to say like segment or angle when we talk about reflexive or things like that. So these are about angles. If T is congruent to V and V is congruent to R, then T is congruent to R. So we just need to say transitive. That's it. And then finally, the last one, we can see that would be symmetric. The end.